Hey guys, good afternoon. I'm Prashant. I take care of platform engineering at Myntra. And
And I am Abhishek Jain. So I am presently working as technical lead in platforms team at Myntra.
I hope guys know about Myntra. How many knows about Myntra? Yeah, so it doesn't need an introduction. How many have done shopping at Myntra? Purchase? Oh, that's cool. So we don't need much of the introduction. We'll start the slide. Yeah.
Yeah.
So I think yeah, cool. So why Redis, I think, just go to the next slide. We just wanted to capture a lot of stuff that we do at Myntra. And almost every service definitely uses Redis. So few things we just wanted to pull in here and wanted to bring it at the notice. But I think the main story are in the next slide. So we should actually jump, and I'm going to share 3 small stories, like how are we using Redis for different cases, mostly like solving high complex problems. And yeah, now Abhishek, you take over.
So any B2C product essentially needs basically a segmented kind of a platform wherein you can create segments for A/B experimentation, personalization, or any kind of behavioral analysis. Now, if you want to do these analysis, you want to create certain cohorts. A cohort is nothing but a set of users, which could be over different kinds of parameters. It could be, let's give an example wherein you want to run any kind of an experiment or any kind of personalization just for people in Karnataka. And let's say not even people, just men among them and who have affinity to a certain brand. For use case of Myntra, there is a concept called as brand affinity, what you basically search the most, what you basically purchase the most. So let's say you have affinity to a particular brand and we want to create a segment around that. Now the problem with that is that creating that segment, creating that query, running that query would take a lot of time. It would basically, that is an offline process. You need to search through your database, you need to run a query, you need to set the users into a certain, basically a group, and then a segment would be created. Running those queries, we have seen those can take anywhere around from 5 minutes to about a couple hours even. But the segment basically, the mapping of users, basically, you need to know that this user is present in this segment or not, that needs to be at a live traffic. Basically, that needs to be at a very low latency. So the requirements that we had with this segmentation service was it needs to support high read throughput. Throughput was at a range of about 5 million requests per minute, and the latency should be under not more than 5 milliseconds at all. Service should also be scalable to support next few years. It should basically, let's say your throughput increases from 5 million to 10 million, or it could be much more than that. How do you basically support that? So Redis basically came out as a perfect solution here. We evaluated other databases also. We evaluated MongoDB for that. We evaluated Cassandra for that because write throughput is extremely, basically extremely heavy at Cassandra, but what about reads? The problem here is that the writes essentially at our segment service, this segment service would be not very much. Basically, writes would happen couple of times in a day, but the scale at during those times, the writes could range from 10 million to 100 million queries. So you might end up updating your entire user base with new segments. So it could range from 10 million to 100 million, which is kind of an entire user base of Myntra. And what we did is segment creator essentially was our producer, wherein we are actually creating that offline segment, which has run via a query of couple of hours. Using that segment creator, we created a segment wherein one segment essentially contains these many users. So it could range from 10 million to 100 million users. Now, that segment creator would produce that to our Kafka queue, and Redis, this segmentation service, which acts as a consumer, it consumes from that Kafka queue and caches that in Redis. Redis is used just as a persistent data store here. Basically, there is no other databases behind Redis which will be storing that data. The reason for that is basically persistent DB. Why we use Redis just as a persistent DB is because we didn't want to, fall into any kind of latency issues with other DB during failover cases. How we handled
Yeah.
failover cases, I'll talk a bit about
Yeah,
that.
if I may add here
Yeah.
a little. So, as a persistence, I think we always have imagined either RDBMS or
Yeah.
NoSQL, something like that. But can we persist like 100 GB of data in Redis? So that something was
Yeah.
really, really interesting, and we successfully did at Redis. Most fundamental thing with the Redis as a persistence also is like data migration. So we recently did a migration also, and it's pretty easy. I think later there is a one slide where we will explain more about migration, backup, and all that.
Yeah.
So persisting like 100 GB and having like a cluster size of maybe 50 Redis nodes, it's a pretty beautiful system to store data, which provides a very low latency and very high throughput. Throughput could be like 5 million RPM, and the read is always fast in Redis. So that's something which we did beautifully in this segment service.
Yeah. And there were essentially two problems while creating this service, which there was one problem essentially, sorry for mistake, which we encountered during creation of this segmentation service. Whenever there were writes, because as I told that writes would happen in the range of anywhere from 10 million to 100 million. Now writes also need to happen at a certain rate, basically after the creation of segment, it has to be live within a few minutes. Because of writes, read throughput completely gets throttled. So the latency which was under, let's say, 5 milliseconds, that happened to be up to a level of, let's say, 100 milliseconds, even to 200 milliseconds that we have seen. That is not acceptable. How do we solve that problem? There are two ways, basically, we solve that problem. One is we did throttling at Kafka level itself. But the problem is if we throttle too much at Kafka, your segment wouldn't be created in time. Another way we basically solved that problem is we made your read pools and write pools completely separate. So write pools would only serve your write traffic. Write pools, because write traffic is not only just for writing to Redis, but there are certain other things that are happening in background for that using Redis pipelines, wherein we are expiring the segments that are no longer valid. Because we actually don't use Redis TTS here because the segment is used as basically a list of segment IDs which are present for that user. But the key, at key level, at user ID level, we cannot set an expiry. Otherwise, all the segments would expire. So there are certain things that happen during that write pipeline. Because the Redis pools were made separate, therefore there was no throttling during for read connections. The connection pool for read was kept separate, write separate. Your read is happening at a smooth rate, your write is happening at a throttled rate.
So I'll take over there. Yeah. Just a quick trivia. Segments in Myntra are like pretty interesting also. Like people who wear black shirts, people who does shopping in the night. So a lot of things that we try to segment as a user. Like people who sits more in the left side. It's very difficult. I mean, predicting all that stuff is going to come in the future, but we have planned to actually segment on the very intelligent levels also. Now I'm going to talk about a new story. Scalable mobile verification platform. So in platform service, we have one of the service which does the authentication. So we wanted to build a scalable authentication service using mobile verification, means OTP. So today I heard one more story, Amit, I think, shared already.
Yeah.
So maybe I'm going to add up some value to your story by introducing that how did we solve the problem and made it happen for future scale also. So OTP generation, yeah, that's one part. And it has to be really large. I mean, RPM, currently we started, let's say, 100K RPMs. Means that many queries per minute, which means in a whole day, it could be something around, 100 million approximately.
Like yeah.
But what if the, this number is doubled next year? What if in the next 10 years, it becomes 10 times? Can the system take this kind of a stress? So that's how we think at Myntra, like how do we design the future? How do we make system which works for next 10 years? And that's one of the solutions we wanted to bring to the audience where Redis also plays one of the vital role. And availability. Like suppose if the OTP sending, let's say someone is trying to log in and somehow OTP is not going or something fails, like it's a disaster, right? I mean, we wouldn't want to really have it, right? So another one is like suppose if a lot of OTP has been generated and users are authenticated, we would want to store that also. Why? Because at a certain level of authentication, we also identify there is a pattern of fraud. A lot of people trying to hack others' account, right? A lot of people have password like welcome, India123. So it's very simple to hack. So identifying that pattern is also one of the aspects where we wanted to store also. So these are the problems. Like then now, how did we solve it? Can we have the next slide?
Yep.
Yeah. So we introduced a new data store system. We call it augmented data system, where we use Redis as a transient store. Yeah, I mean, there is a significance in calling it transient store. I'll explain why. And also, something for persistence. Let's say I use Redis, then I am easily achieving very high throughput. Like you can get easily like 1 million RPM or 5 million RPM with a Redis cluster, very easy. But I also want to persist it and I also want to query it. I want to find out the users who are coming from Bombay in the night 12 o'clock to 1 o'clock. I mean, how do we do that? With such kind of a very high throughput and persistent and identifying fraud, all that, how do we solve at a time? So that's where augmented data system comes in picture. One of the interesting part of OTP validation is this data is ephemeral. Like I want to store it only for 15 minutes. After that, OTP expires. So I don't need to store for a longer time. So the previous system was based on some RDBMS. Anybody can use MongoDB, Postgres, MySQL, and easily store. But suppose if you're validating daily 100 million, data store will not be able to take care of this, right? So we thought of first as a transient store in Redis. So we store that data in Redis, but we use intelligently asynchronous mechanism to persist it in some NoSQL database. As of now, we are using Cassandra. As you can see in the picture, so when it is in transient store mode, it will actually work only on Redis. Read, write, everything Redis, single source of truth. But asynchronously, it's working everything on Cassandra. Why? One, for persistence. Second, what if one of the day, let's say imagine 30th February 2022, usually doesn't happen because Redis usually doesn't go down, right? But what if for a minute it goes down? We designed that also, and that's where we change the mode from persistence, from transient to persistence, and everything will work on Cassandra. Everything moved. Now let's say Redis comes back. How do we bring it back again? So we change the mode again to cache. Now Redis acts as a cache, which means all the request comes, it doesn't find in the Redis, cache miss happens, it goes to Cassandra, pick it up, and put it in Redis and goes back. Then after 30 minutes, everything is back in Redis, and life is set. We change the mode again to transient, and everything works on Redis. So that's how the augmented data system that we designed, which is highly resilient, will never ever fail, will work for next 10 years and super scalable.
Now, talking about another one of the use cases, so A/B testing experimentation, which I briefly introduced during Redis segmentation service. So for any kind of B2C product decision making you need to take, I am sure all the people basically here definitely knows what an A/B testing system is. So there could be a bucket A, it could be a bucket B. You basically test between the two, and you you start with an hypothesis, validate that hypothesis, and go along with the whatever is performing better.
Just to explain a little bit on A/B test, I think a lot of people are already aware, but one for no-brainer. Where do I put this? I put it here, I put it there. I mean, how do I make a choice? How do I decide? I put it in the blue color or black color. That's how, I mean, like, if you decide or the whole hall decides, it's still like a bias, right? Out of 100 people, let's say 90 people is saying, but it still is a bias. So there is a statistical approach of finding out that how to make a decision based on certain statistics. And that's what we call A/B test. And Myntra heavily uses. At any point of time, if you are shopping in Myntra, you are running under experiments, at least 30. So it is very, very important. Yeah, okay, carry on.
And let's say, so for A/B testing system, basically we use Redis for two purposes. One of the purposes wherein you persist the bucket, which is in our persistent data store, Cassandra, but to query that, you cache that data, which is where Redis is acting as an LRU cache. But another purpose is, let's say, basically one of the more interesting use cases where we use Redis as a distributed locking system. Now, how do we use that and what are the benefits and cons for that? That I'll explain in the next slide. First of all, let me introduce you to slots, why we needed a distributed locking system. So slot is nothing but a set of users so you divide your entire Myntra user base into random set of certain users. And so we divided our Myntra user base into 10,000 slots. Each slot was have certain set of users. Now, a slot needs to be associated only with a single experiment. Why? If let's say two experiments or two or more than, basically more than two experiments, let's say are running over a single slot, and you are running a hypothesis, how do you know that basically that hypothesis was because of first experiment or was because of second experiment? Basically, you are measuring CTR, let's say click-through rate. How do you know your CTR increased due to first experiment or due to second experiment? So you need exclusive experiments for that. So each slot would be associated with a single experiment, and that's how basically slots divides your user base and your experiments in that manner. Now, whenever a user is creating experiments, there can be concurrent users. There can be multiple concurrent users who might be creating multiple experiments at the same time. And what could have happened is that because there are two separate users, they could select same slots. They basically, because the system is assigning the slots automatically based on certain criteria that system is defined, how do you ensure that both the users don't get same slots for their experiments? For that purpose, we could have used RDBMS, we could have used transactions, basically could be a transactional for you. We could get transactional lock at DB level and basically divide the slots. But we decided to use MongoDB because we needed to use a document data store for certain purposes. And how do you make now MongoDB query transactional? So to do that, what we did is we started using Redis as a locking service, wherein, now let me explain you this flow a bit. Basically, in the interest of time, I'll fast forward it.
It's a little complex.
Yeah, just a little
Can we
bit.
make it simple?
Yeah, so to be extremely simple, basically what client one comes, he acquires the lock, and basically Redis gives a response that yes, you have acquired the lock successfully. What could have happened is GC pause can kick in at any time during your basically any application that is running on server. So release lock basically failed because of GC pause. But what Redis provides is expiries. So you can, over that lock, you can get an expiry. And as soon as that lock expired, now your client 2 moves out of hang mode and basically moves to get a lock, successfully acquires the lock, gets the data, gets its jobs done, basically writes to database for that persistence, gets the slots that it needs for the experiment, and returns as an OK. Now, client 1, after some time, what happens is moves out of GC pause. It would come out of hang mode and tries to basically get the same slots by writing to database, by basically querying the database. Now it is our database or our code's responsibility basically to reject that data. So if it is trying to basically acquire the same slots. So that's how basically a combination of your code, your database, and Redis, the whole distributed locking system works. It becomes an extremely powerful tool to basically make your non-transactional query transactional. Now there are certain issues with this. What if during acquiring the lock, a network issue happens? Lock cannot be acquired. During releasing the lock, or basically during getting the response, a network issue might happen. How do you mitigate from those issues? Also, because Redis is in a cluster mode, basically lock would be at your single node. What if that node goes down? What do you do? So those all things are handled at code level, but Redis as a service, it provides you a distributed kind of a platform because basically at that distributed, at that separate cloud layer itself, you can basically get a simple kind of a lock, and rest all issues basically are mitigated at code level itself. You can retries, if the request fail, you can retry, or certain kinds of flows that you can do. But basically,
Yeah.
Redis does,
Timer.
yeah, so
I think
basically,
that's good.
we'll,
Yeah,
I think
essentially
run around
like
that.
Redis provides a distributed lock, provides expiry, all that. So it's a very beautiful tool to make non-transactional database also a transaction. Just
Just to
quick
basically-
minute, we are also working on managed service Redis. I think after looking at a lot of presentations
insights
and the
today.
Redis growth at here, we might think of not to do it. Let's see, because Redis is already working a lot of things on making it managed. So
yeah.
one-click deploy Redis cluster. That's the kind of thing that we did in the Myntra. Monitoring stuff, backup, replication, migration, all that.
Almost, I mean, you can,
Yeah.
if you, let's say, want to increase your node at runtime, basically, with one-click deploy itself, you can do that. I mean, these were kind of things that
in
we
the
were
Redis
trying to
cluster,
do in the Redis
that's
cluster
one of
itself.
the very pertinent requirement, right? Increasing the cluster, reducing the cluster size.
Reducing the cluster size at runtime. But looking at today's presentations, definitely we'll see what
Yeah.
will be
Sure.
a future roadmap for this as a
Yeah.
managed service.
That's all for now. Thanks a lot, guys.
Thanks a lot.